Being recorded. Uh-huh. As usual, one person.
Hi.
How you doing?
I'm doing all right. How about you?
Good. Did you get a chance to see the my recording from Tuesday about black body radiation and wavelength and frequency, etc.?
I actually didn't yet. I've been really sick.
Oh dear.
Yeah.
COVID?
Not the best. I tested negative for COVID, but some kind of other viral thing and a wicked sinus infection. And this is my first day back to the grind.
Oh, okay. Well, that won't really matter. But just to reiterate what I did that day, we talked about the relationship of wavelength, frequency, and energy. And so I wanted to do a few problems from that. So, and they're not too bad. So it's kind of the hairiest part of the math for these two chapters. So let's just go ahead and get started. So I am looking at sample problem 1.A, I believe, from the textbook. And the problem is, if you have, and I'm not looking directly at the printout for that. Let me just glance at it again. Oh, that's not really going to work. Okay. Come on. Did it go away? Come on. Okay, are you still there?
Yep.
Okay. Oh, hi, Josh. How are you?
Pretty good.
There it is. Okay. So the problem is basically, even if you're not looking at the textbook, you are given a wave which has a frequency of 7.23 times 10 to the 14th hertz. Okay. In other words, that's how many times it goes across the x-axis in 1 second. So a hertz is the same as cycles per second. And you might also see it abbreviated second to the -1. So, and I think we talked in that video about, the energy of waves, and we looked at how if the wavelength gets bigger, okay, then of course it's not going to go across the x-axis as many times. So the frequency will go down. And so we say that that's an indirect relationship, which means that wavelength times a frequency equals a constant. Kind of reminds you of Boyle's law, right? Well, it turns out that the constant is the speed of light in a vacuum. And that is 3.00 times 10 to the 8th meters in a second. Wow. Okay. That's pretty incredible. So if you know the frequency, you can find the wavelength. And if you know the wavelength, you can find the frequency. So let's do it. So we've got, we don't know the wavelength, but we know the frequency. And I'm going to use 1/2 here. And that equals 3.00 times 10 to the 8th meters per second. All right, so we're going to take that out of there, put it under here. And that's pretty easy to get in your calculator and get the answer. The only thing that I have students struggle with is they want to use that caret key on the calculator, and that's not good. So no matter what, always put parentheses around your denominator, okay? I think that you get Well, grab your calculator, see what you get.
I got the same.
Okay, good. Okay, now what unit is that? Okay, so the seconds cancel out, okay, and you're left with meter over 1. Okay, that's meters. But in the original question, it asked to change it to nanometers and then also to angstroms, okay? So let's look at that. So 4.14 times 10 to the minus 7 meters. Now there's, for every 1 meter, there's 1 times 10 to the 9th nanometers. And, you know, you probably don't even really need to use your calculator for that. You should get 414 nanometers, okay? An angstrom is 10 times longer, so it would just simply be 14140 angstroms, okay? So make sure that you know those different conversions, okay? 1 meter is 10 to the 9th nanometers, and that's in your textbook. And 1 meter is 10 to the 10th angstroms, right? It does ask you what is the, I think it asked you what region it's in, and it should be in the visible range, and it should be purple, a purple wavelength. I don't know if you took high school chemistry, but do you remember doing a thing called the flame tests, where you took a chemical and you burned it in the Bunsen burner? Do you remember doing that? And they were different colors. So that's what we're doing here. Okay, so we can see some of these waves. We can feel some of these waves. Some of them we can't. But there's a tiny little portion of the electromagnetic spectrum that is visible. Okay, any problems with that one? Do we need to do another one?
I think I'm good.
Okay. All right. Okay. Share content. Whoops, what happened to my whiteboard? There we go. Okay. All right. On to problem 1B, and in the textbook. Oh, this one is just what is the frequency if you know the wavelength. Okay, so you're given a wavelength of 940 nanometers, and we need to know what is the frequency. All right, so you still have that same equation, 3.00 times 10 to the 8th meters per second. All right, now we got a problem here because these units don't match up. And if there's one thing that happens with chemistry students, it's not minding their units. So don't forget, there's 10 to the 9th nanometers for every meter. So that's probably 9.4 times 10 to the minus 7 meters. Okay. All right, let's see what you get.
I got
Now, don't forget 1/seconds is the same as hertz. And yes, that is the same thing that's on your radio when they say megahertz and all that. And that's those numbers, those call numbers for radio stations are frequency modulation numbers, FM, if you listen to FM. And if you listen to AM, that's amplitude modulation. And those are radio waves. And the reason that here in higher population densities that we use FM more than AM is because they can reach a lot of people with a high energy wave. It doesn't go very far, okay? It doesn't go very high. Amplitude modulation is for those, those places, out in the country where there's mountains and stuff, and there's little people, and they live by the mountains. Well, those radio waves are great, big, and tall, and so they use AM radio stations. Just a little tidbit of info there. Okay, on to problem 2A. And in this problem, let's see. I wish I had those problems up in front of me. Let me see if I can pull up the textbook. 2A is from the, there we go. Okay, cool. Hang with me. Okay. Okay, so we are given, we want to calculate the wavelength in nanometers and calculate the wavelength and the frequency of a photon, which has a certain energy. Okay, so we're given an energy of a photon. Make sure you read about photons, okay? Because they're a little hard to describe, but they are a particle, but they have no mass. And like a lot of things in chemistry, it was just a way to describe what phenomenon the scientists were observing. So energy in this instance, for this particular wavelength and frequency was 8.2 times 10 to the minus 19 joules. And that's, by the way, per photon. Okay, so the question is, what is the wavelength? And what is the frequency? Okay, well, it turns out that energy is equal to Planck's constant, or Planck if you want, times the frequency. So we've got the energy. And we're going to divide by Planck's constant to get the frequency. Now, Planck's constant is 6.626 times 10 to the minus 34 joules per second. I think that's the unit. Joules times second, sorry. Times second. Okay, so joules are going to cancel out, all right? And you're going to be left with, of course, 1/seconds, whatever your number is. So go ahead and calculate that. Let's see if you get the same answer I do. And, I'll make sure I get it right. And if you have a different answer than me, then one of us is right and one's wrong. So it could be me.
I got the same as well.
Cool. All right. And of course, that's hertz. Okay. So now the question is, we've got the frequency, but we can get the wavelength as well. And don't forget that if we take the speed of light and divide by either the frequency or the wavelength, we're going to get the other. And see how you do. It's getting windy out there, isn't it?
I got the same as you. It's pretty
Okay.
bad for you.
Yeah. Now, by the way, what unit is that going to be?
Should be in meters.
That's right. Okay. So be careful with that. So I've done some with nanometers here and with meters, just to kind of emphasize, you got to kind of watch out for that. I think there was a question on the test. It was the very first one, in fact, where I gave the units to begin with in joules, and then I asked for the answer in kilojoules. And most people, caught that little thing. So that's good. So be careful with those. As far as units, I don't know if you've worked with joules much before, but that's the unit of energy. And joules, just in case you're interested, because when you're doing some of these calculations, you might be wondering, how does the speed of light cancel out? So joules are actually kilograms times meters squared over seconds squared. Now, I'm not going to ask you to ever prove that, or, do some kind of weird proof of what the units are in something. But as far as our class is concerned, if you're looking for wavelength or something, like that, then if you're using joules, then that your wavelength is going to be in meters. So I'm not really going to try and trip you up by trying to have you show me the cancellation of the units. But if you take physics, you'll use that equation a lot. And by the way, it's made up just like all the other units that we use. It's just a made up number. If you ever want to go down the rabbit hole of looking at units, look up the units of pressure on Wikipedia or something like that. There's probably 500 different units of pressure. And as you know, with gas laws, we used atmospheres, we used kilopascals and millimeters of mercury, but that's just a few of them. Okay. That is it for the calculations in chapter 7, as far as I know. Let me just double check. And in fact, we're not really doing too much more of chapter 7. We will not, by the way, be looking at quantum numbers at all. We're not looking at quantum numbers at all. We will, in chapter 8, be looking at electron configuration. And I have a real easy way of explaining that. And in my opinion, that's probably one of the hardest things to read about and understand. But I can explain it in about 5 or 6 minutes, and it'll be more than enough information for you to go on for the rest of your life, probably. But if you really want to know about the physics of all that, knock yourself out and read about it in the textbook. But I am going to explain it in a very simple manner for everybody, probably on Tuesday, or I might send out a video over the weekend. We'll see. So is there Has anybody got any questions again from the test? Anything there? I don't think, oh yeah, I've graded it. I don't know if you saw your grades. I just finished a few minutes ago. So if there's anything there that I can answer, or you can send me a personal email and I can send you a little video on that. Is there anything I can go over there?
You answered most of my questions Tuesday, so.
Okay, okie doke. Thank you. Anything else, Whitney?
I don't think so. I
Okay.
just didn't get to complete the whole test based on illness stuff. So I just did the best I could. But
Yeah, I noticed. I think you left out.
I just reached my max point of being able to sit in a chair.
Yeah, no,
and
you did
hitting it.
okay.
It's better than nothing. So
Yeah, you did fine. There was one, and I was like, "Wow, did you not see it or what?" So,
I'll look back at it, and if I now that I'm in good state of mind again, can't come up with an answer, then I'll shoot you a message.
Okay, sounds good. All right. Well, unless you have any other questions, that's really all I've got. And just stay safe in the wind and all that. And hope you feel better, Whitney.
Thanks.
Okay. Take care.
Thank you.
Okay, bye-bye.